Good morning. Again, we want to discuss the subject physics. In the previous classes, we have started atomic and radioactivity, everything. Today we can start the X-rays. So immediately X-ray means immediately the scientist Rontgen comes into picture, because X-ray was invented by the scientist Rontgen. When the fast moving electrons are suddenly stopped by any metal target, the outcoming rays are X-rays. So very fastly the electron comes. So it should be suddenly stopped by any metal target, the outcoming rays are X-rays. These X-rays can be produced by the instrument called Coolidge tube. Coolidge tube is an instrument used to produce X-rays. The wavelength of X-rays from 1 angstrom or few angstrom to 100 angstrom. Intensity of the X-ray can be controlled by the filament current. The penetrating power of the beam is controlled by the potential difference. So you have to find the filament current and also potential difference. The intensity, some X-rays are more intensity if you are having more filament current. If potential difference between the positive and the negative plate maintained very high, we are having the penetrating power is more. Intensity and penetrating power depends upon filament current and potential difference. So this is our diagram for X-rays. This is a relative intensity, energy, a graph. The intensity going on increases some sharp point, that is L line. Then it goes K lines, lighter, some humps. The spectrum is called continuous X-ray diagram. It consists of continuous range of wavelength starting from a minimum value. Superimposed on this is a characteristic line spectrum having sharp wavelength. That is sharp length L. Yeah, there is a line spectrum we are getting. That is called actually a continuous X-ray spectrum. In the continuous X-ray spectrum, we know the value of h nu is equal to E into V. We know E hc by lambda, that is mu max, lambda minimum is equal to E into V, or lambda minimum is equal to hc by E into V. So h Planck's constant we know, c velocity of light 3 into 10 power 8, E charge of an electron. Substitute these three are constant. Therefore, once we know the potential difference varies, automatically wavelength can be calculated. Nearly 12,400 divided by V angstrom. So this is a minimum wavelength. From this wavelength up to infinity, we are getting with a continuous background. Since we are getting the continuous background, they are called continuous X-ray. Similarly, characteristic X-ray. Why we call this characteristic X-ray? This X-ray tells the character of the target element. We know electronic configuration. So this is K shell, L shell, M shell, like that. In the K shell we are having 2 electrons. In the L cell we know 8 electrons. Electronic configuration, everyone knows. So I want to knock the electron. This is a nucleus. It is very difficult to knock the electron from K shell than any other cell. What is the reason? Knockout means we have to remove the electron from its place. If I remove the electron from K shell, it is very difficult than any other cell. What is the reason? Everyone aware of it. The K shell is very nearer to nucleus. Nucleus is positive charge, electron negative charge. Therefore, electrons in K shell are very much attracted by the nucleus. So that it is very difficult to knock the electron from K shell. If I remove this electron from the K shell, in order to fill this vacancy, electron may jump from L shell to K shell. When electron jump from L shell to K shell, the difference in energy emitted as radiation, that radiation is called characteristic X-ray. And also this is called K alpha line. K alpha line. In order to fill the electron not from L shell, it may be from M shell to K shell, K beta line, like that. Similarly, if you are able to knock the electron from L shell, there is a vacancy in the L shell. In order to fill this vacancy, electron may jump from M shell to L shell. That is called L alpha, L beta, etc. Like that, we are getting a line spectrum that is called characteristic spectrum, that is tells everything for us. This is the thing we have to understand. This is given in the chart. If an incident electron collides with an electron in one of the inner shells and knocks it out of the atom, a vacancy is created. Another electron from a higher shell makes a transition, so it can to occupy that place to this shell, creating another vacancy continuous till the inner cells are filled up. Generation, radiation, and the characteristics of the target element classified into K series, L series, and M series. So this was explained by the law. That law is called Moseley's law. The frequency of a particular spectral line, particular spectral line in a characteristic X-ray spectra related to the atomic number as nu is equal to A into Z minus B the whole square. Nu, the frequency always equal to A into Z minus B the whole square, where Z is atomic number. Once we know atomic number, we can fix what is that element. Nu is the frequency. Z minus B, where A and B are constant. Origin of continuous spectrum, just now we have discussed. If an electron comes very close to a target nucleus, it is suddenly accelerated due to the Coulomb field of the nucleus and emits electromagnetic radiation called Bremsstrahlung and is continuous. It is called the word we have to use. If accelerating particle or if accelerating potential, just now I have given this formula, h nu maximum is equal to h nu maximum is equal to hc by lambda minimum, that is equal to EV, lambda minimum 12,400 I have given, or accurately 12,420, but approximately we can take 12,400, that is also correct answer we can get. The properties also, the intensity, the X-ray may be absorbed, just like our on light rays, X-ray can be absorbed. So if X-ray passes through a material of a thickness dx, then I is equal to I naught e power minus the formula mu x. Just like that, n is equal to n naught e power minus lambda t. The X-ray actually absorbed by the material. I naught is called intensity of incident radiation. I is the intensity after traveling through a distance x, mu absorption coefficient. Therefore, I is equal to I naught e power minus mu x. This formula actually relates how the intensity is absorbed by the material. If it passes through the material of distance x, automatically I is equal to I naught e power minus mu x. Everything we can calculate that. Another one is called the diffraction of X-ray. X-ray also diffracted by ordinary when compared to light. I already discussed you that it is very difficult to understand light diffraction because its wavelength and also its velocity. But whereas X-ray still shorter wavelength, we cannot explain X-ray diffraction by using glass grating. So that we should depend some other method. Crystals are used to diffract X-rays. That is called crystal diffraction. This was explained by the scientists W.L. Prof and W.H. Prof. How these are the crystals? We know crystals are one in which atoms are arranged in regular manner. Where the atoms are arranged in a regular line, that line is called lattice line. The distance between the two lattice lines are equally spaced. Then the diffraction X-ray can be explained. If an X-ray of monochromatic X-ray gets reflected, another X-ray also gets reflected to the second lattice plane. The distance between two lattice plane is d. Then we have to find the path difference. So this is a total path difference. The total path difference is nothing but 2d sin theta. If 2d sin theta is equal to n lambda for combination, this 2d sin theta is equal to n lambda is called Bragg's law. Bragg actually formulated a law. That law is called Bragg's law. What is called d? D is called crystal spacing. Once we know theta, theta is nothing but a glancing angle, n is an order, lambda wavelength of X-ray. Once we know, we can able to find out the wavelength. Actually, the wavelength of X-ray can be calculated by a spectrometer, that is called Bragg spectrometer, in which lambda is equal to 2d sin theta. Everyone knows the value of d. From the Bragg spectrometer, we can able to find out the value of theta. What is called theta? Theta is nothing but glancing angle. Once we know the glancing angle, substitute it, we can able to find out the value of wavelength. But you have to keep your mind, 2d sin theta is equal to n lambda. So that is given in the paper. So this completes your X-rays and everything. So why I am telling that? In the chapter, we have to thorough on atomic physics and also in nuclear, next topic nuclear physics. In various aspects, we have to think it of the Thomson's method and Millikan's method in atomic physics, in atom models, everything I have given, and also photoelectric effect. This is the combined the thing that is called three-dimensional one, that also Planck's law, that is called quantum theory, how de Broglie used, how Einstein used quantum theory for his explanation, everything we have sorted out in the previous classes. In which way we are going to solve the problem? There are some problems given in this initiation, so it is our duty to solve the problem. Very first problem, in a Thomson setup for the determination of E by m, electrons accelerated through 2500 volt enter the region of crossed electric and magnetic fields of strength 3.6 10 power 4 and 1.10 power minus 3 Tesla and the speed of electron. So In this problem, there are two questions asked. One is we have to find the value of specific charge, E by M. Here two electric fields are applied. If the two electric fields are applied means both are balanced. From the application of the balance, so kindly imagine our discussion in the very beginning of the class itself. There are three methods. One is only magnetic field, only electric field, both will be there. If both the electric field is there, we know both are balanced. That means the value of electric force E is nothing but the magnetic force BQ. That is BEV average. E getting cancels, automatically V is equal to E by V. That is electric field divided by magnetic field. What is the electric field? That is 3.6 into 10 power 4 by the problem divided by 1.2 into 10 power minus 3. So 1.2 into 3.6, everyone knows 3 times. This 10 power minus 3 goes to the numerator, 10 power 7 meter per second. This is okay. This is the thing I have given in the previous classes. But this method is also in your 12th standard state board syllabus. So here both the fielders are applied. Because of the both the field, we can able to find out the velocity. If any one of the field is removed, so in our syllabus, we can remove the magnetic field, only we are taking the electric field. Or sometime we can remove the electric field, we can take only magnetic field. Like that we have to choose. But in this case, it is entirely different. In this problem, I have given already the value of mv square is nothing but E into V. This is another method I have given. Very first class itself, I have given this formula. So from which also we can able to find out the value of E by M. So M goes there, V squared by 2 into V. V is the potential. But V is nothing but E by V. Therefore, E squared by 2B squared V. So this is the formula, you can make it up. So due to energy, so you have to keep your mind in order to solve the problem, how can within the given parameters, that is an important thing. Immediately E by M, simply we cannot use all the formula. What are the parameters are given? In this chapter we are having the parameter only the electric field and magnetic field and also potential. Within these given parameters, how the energy equation is there of mv squared is equal to EV. Sometime h nu, whatever may be the thing. So in this it is easy. So just now we know the electric field E 3.6 into 10 power 4 the whole square, whole divided by 2 into B 1.2 into 10 power minus 3 Tesla the whole square into V, the accelerating potential in the given problem 2500. So set up determine E by M electron accelerated through 2500 volt potential. On simplification, this value become 1.8 into 10 power 11 coulomb per kilogram. So once we have to calculate the value of E by M, once we have calculated the value of E by M means that should be in the coulomb per kilogram into 10 power 11. We already given in the theory itself. So this 1.8 or 10 power 11 comes like that. This 10 power minus 6. If it goes in the 10 power plus 6, that is 10 power 8, 10 power 14. This 10 squared is there. 10 power 12. So everything, that is 1.8. This 2500, 1.2. So on simplification, everything is cancelled out. The value should be in the order of 10 power 11. So you have to keep your mind, if specific charge of the electron calculated by using the formula E by M, the value should be coulomb per kilogram. and also into 10 power 11. Whatever may be the thing, we have to understand it. This is the first problem. The second problem, find the number of photons emitted per second by a 25 watt source of monochromatic light of wavelength 6000 angstrom. So here also find the number of photons emitted per second by a 25 watt source of monochromatic light. I already given so many information for luminous flux, luminous intensity, luminous efficiency, everything you have to keep your mind. In this case, N is called number of photons. So simply we know h nu is equal to E, energy. So number of photons, N means N into h nu into E. Therefore, I want to find out the value of N, E divided by h nu. Everyone knows E divided by h nu. But we know everything C is equal to nu lambda, therefore nu is equal to C by lambda. This equation can be modified according to the given parameters. E divided by h C, this lambda goes in the numerator. Now given parameters, find the number of photons emitted per second by 25 watt source of monochromatic light of wavelength. Therefore, E is given as energy 25 watts and wavelength is given as 6000 angstrom. So 6000 angstrom means 6000 into 10 power minus 10 or 6 into 10 power minus 7. Whatever may be the thing, we have to use. The whole divided by h, you are supposed to be known, plus constants 6.63 into 10 power minus 34 into C also you are knowing 3 into 10 power. On simplification, the number becomes 7.54 into 10 power 19. 7.54 into 10 power 19 number of photons emitted per second. So here you are asking question by yourself. If it is a very difficult problem, how can you solve this? So first you have to solve the thing. You just told you that 10 power minus 7 in the numerator because minus 9, minus 8, minus 7. This 10 power 8 goes in the numerator, 8 minus 1 become 10. This 34 goes in the numerator, plus 34, 10 power 35. So on simplification, we can get the value of 10 power 19. That is the first you have to think, the thing minus 34. That is 10 power 8. So we have to substitute everything, we can able to find out the answer. So the third problem, the work function. Immediately if we see the problem itself, we can come to the conclusion about the work function. Work function, the question asked in the work function means immediately instance photoelectric equation comes into picture. What is instance equation? The intensity or incident energy is not only produce electron and a huge amount of energy utilized to increase its kinetic energy. This amount of energy utilized for the ejection of electron is called work function. And also in the results of photoelectric effect, not all the frequency the photoelectric electrons are coming out. There must be a minimum frequency necessary for the ejection of electron. That minimum frequency is called threshold frequency. Therefore, the work function h nu naught. That is a thing we have to understand it. So here hc by lambda naught is equal to W. Why? We know work function is always h nu naught. That is called work function. H into C is equal to nu lambda, nu is equal to C by lambda, that is C by lambda naught. So, given parameters, I have to convert it. That is the thing. Work function W is equal to H nu naught. Nu naught is called threshold frequency. The threshold frequency in terms of velocity of light and wavelength, it is modified as Hc by lambda naught. So here I want to find out the value of lambda naught is equal to Hc by W. So given parameter, we know Planck's constant 6.63 into 10 to the power minus 34 into velocity of light 3 into 10 power 8. The whole divided by the work function given the problem 3.45 electron volt. So that is the thing you have to understand it. The electron volt converted into energy, that is in joules. How can you convert it? That should be multiplied by 1.6 into 10 power minus 19. On simplification, 3.603 into 10 power minus 7 or 3603 answer. So because 3.603, 36 minus 8, 360 minus 9, 3603 minus 10. 10 power minus 10, 1 angstrom. Therefore, the wavelength, the work function of the metal is 3.45 electron volt. What is the maximum wavelength of photon? Because frequency is minimum means wavelength is maximum. So that the problem asked in this way. There must be a minimum frequency for the ejection of electron called threshold frequency. If the frequency is minimum means in terms of wavelength, that is called maximum wavelength. That is the thing we have to understand. This problem is concerned. Are you clear? Then problem number 4. This is also easy problem for you to understand. Find the de Broglie wavelength of electrons accelerated through a potential difference of 100 volt. I want to find out the de Broglie wavelength. De Broglie wavelength potential alone given. I have given the shortcut formula also. Are you able to follow what I say? Find the de Broglie wavelength of electron. I have given in the theory itself. General formula, lambda is equal to h by mv. So in terms of electron, I have the accelerator of mv square is equal to ev, from which the entire formula is modified for electron alone. Kindly go through the previous chart. That is root of 2me into root v. In the chart I have given 2m ve. So I separate root v. Because we know h, Planck's constant 2m, everything is known. I have given shortcut the formula 12.3 by root v answer. So this keep your mind, because h is a Planck's constant 6.23 10 to the power minus 34, m mass of electron 9.1 10 to the power minus 31, E charge of the electron 1.6 in 10 to the power minus 19. Everything is a constant value. H is root of 2mv always 12.3 into 10 to the power minus 10 meters. Once we know the potential difference, immediately we can call. This is a shortcut technique. So 12.3 by root v, that is called de Broglie wavelength for electron. This is exclusively for electron. Otherwise, lambda is equal to h by mv. We can also start v for h value and mv divided it. And if once we know the velocity of the given particle, we can able to find out the wavelength of the particular particle. So here also 12.3 divided by square root of 100. That is equal to 12.3 divided by 10. That is equal to 1.23 angstrom. This is the wavelength of electron, 1.23 angstrom. This is a direct problem. This type of problem only asked in the NEET. Simply we can substitute, but we can short the values of 12.3 divided by square root of v. Then The fifth problem, very interesting problem. The wavelength of first number of Balmer series in the hydrogen spectrum is 6563 angstrom. Calculate the wavelength of first number of Lyman series. The first number, second number, we have to keep your mind. Calculate the wavelength of first number of Balmer series. The first series is called Lyman series, second series is called Balmer series, third one Passion, fourth one bracket, fifth one fund. I have given a chart for your information. From the chart, here for Lyman series, transition ends with the first orbit. For Balmer series, ends with the second orbit. Therefore, 1 by 2 square minus first number, therefore 3. 3 to 2. Therefore, how can you solve this problem? So, here for Balmer series, for Balmer, the value is nu bar. Nu bar is nothing but 1 by lambda, the revert constant into 1 by 2 square minus 1 by 3 square. Don't forget. So that is equal to R common, that is 1 by 4 minus 1 by 9. That is equal to, what is that, 36. In the numerator, 5 by 36. Therefore, 5R by 36. 1 by lambda value, 5R by 36. Similarly, for Lyman series, everyone know the transition of Lyman series, nu bar is equal to 1 by lambda R into 1 by 1 square minus 1 by 2 square. That is first number. R into 1 by 1 minus 1 by 4. Here also 4 is LCM. 4 minus 1, 3. 3R by 4. Therefore, 1 by lambda. For Lyman series, the question is asked 1 by lambda dash. And dividing this equation, I want to find out lambda dash by lambda is nothing but 5 into 4 by 36 into 3. Because R are getting cancelled. On division, R are getting cancelled. 5 into 4 by 36 into 3. That is nothing but 5 divided by 9, 5 by 27. Very good. So I want to find out lambda dash equal to 5 by 27 into that lambda, the value given as wavelength, first number of Balmer series is 6563 angstrom. So on simplification, nearly I get 1215 angstrom. So this is the answer. So very interesting problem. So this is also repeated problem in our examination. How can you calculate? Once we are giving the Lyman series or Balmer series, this is the first number. Sometimes the same question may be asked. What is the last number? If it is asked in the last number means, how can you find out the last number? Last number means infinity, 1 by infinity. But the first transition is same. If Lyman series, 1 by 1 square. Balmer series, 1 by 2 square. Passion series, 1 by 3 square. Bracket series, 1 by 4 square, 1 by 16. Fund series, 1 by 25, that is 5 square. Minus, first one is 1 by 6. And the first one is 1 by 5, like that. If it is an infinity means 1 by infinity, very easy for us because 1 by infinity always 0. That is the thing we have to understand it. Here also the another problem, the last problem. So like that we have to do so many problems for us. The wavelength of first K alpha X-rays is K alpha X-rays. K alpha X-rays produced by an X-ray tube is 0.76 angstrom. what is the atomic number of the anode material of the tube? So just now I told you that the characteristic X-ray tells the material of the anode. Whenever the fast moving electron suddenly stopped by any metal or target, outcoming rays are X-rays. With the target material, we have to choose with the stand of high temperature. Because when the fast moving electron suddenly stops, it produces heat. In the experimental fact, in the Coolidge tube, the target material always surrounded by a cold water. Cold water is circulated. So that easily we can find out. Number of anode material of that tube. So from which we can able to find out the value of Z. Once we know the value of Z, we can able to find out the atomic number of particular element. So we have to combine the Moseley's law with Bohr's theory. We have to combine the Moseley's law with Bohr. We have to combine the Moseley law with Bohr. Moseley law, frequency. Nu is equal to, I already given the formula. Kindly went through just now today itself we have seen. Nu, the frequency nu is equal to B into Z minus A the whole square. Bohr's theory, the wavelet. So, frequency, that is 1 by lambda nu bar is nothing but R into Z minus 1 the whole square into 1 by 1 square minus 1 by 2 square. So, because K alpha means, I already told you that electron jump from the second orbit to first orbit. So that I put the K alpha. If it is the question, the same question may be asked. Same problem may be, modified problem may be asked. Calculate the K beta. If it is in K beta means we have to put the 3. That is a different. You have to keep your mind. That is equal to, on simplification, 3R into Z minus 1 the whole square whole divided by 4. Or Z minus 1 R the whole square. We can keep that. Is equal to 4 divided by 3 lambda R. Therefore, Z minus 1 is equal to root of 4 divided by 3 lambda. Everyone knows the value of thing. Root of 4 divided by 3 into lambda value given in the problem 0.76 angstrom. That is 0.76 into 10 power minus 10 into R. R everyone knows that is called Rydberg constant 1.097 into 10 power 7. On simplification, this value become 40. Therefore, Z minus 1 is equal to 40. If Z minus 1 is equal to 40, what is the value of Z value? Z is equal to 40 plus 1. Therefore, 41. So, the problem asked here, what is the atomic number of the anode material? The anode material value is 41. Once we know the Z value, we know periodic table is made on the basis of atomic number. If Z is equal to 1, hydrogen, helium, 2, lithium, beryllium, boron, carbon, nitrogen, like that higher atomic number, uranium, thorium, cesium, actinium, rubidium, like that. Once we know the value of Z, immediately we can come to what is the target element. Since it tells the target element, we call this as characteristic X-ray. This is a very important problem, and this is a repeated problem also there. So, this problem tells the entire syllabus to know us. So, this completes our atomic physics. On the next section, we can start our nuclear physics. Thank you.